In this short video of circuit analysis, we will answer a student Meerab's question. The question is that we are given a wave shape for I of t versus t, and it is piecewise linear. It's linear in pieces. It's rising, and it is rising by following a straight line. It's linearly rising between 0 and 2. From 0 to 2 it rises to 10 linearly, then the signal is at 10 from 2 to 4, and then the magnitude decreases once again linearly, and then from 6 to 8 it is 0. So for this wave we know the time period is 8, because after 8 the signal repeats itself. So how to write equation for these 4 pieces from 0 to 2, 2 to 4, 4 to 6 and 6 to 8, and then we can apply the formula and can compute RMS value of this signal. So in this video we will learn how to write equation for these 4 pieces. When we have t between 0 to 2, it's rising like a straight line. We know, and we have studied in colleges, that for a straight line that rises like this, and if we know 2 points for the line and the coordinates are x1 y1 and x2 y2, for any straight line we write an equation. We studied this equation in colleges, that we write it y minus y1 over y2 minus y1, where y is the variable, x is a variable, y1, x1 and y1 are the coordinates of the first point, y2 minus y1 over x2 minus x1, and x2 and y2 are the coordinates of the second point. So this is how we can write equation for a straight line once we are given 2 points on a straight line, 2 points on that straight line, right? So here on y-axis we have I of t, so we can change this equation as I of t. y1 is the value of that y-axis, the variable plotted on y-axis at time t1. X is t, on x-axis we have t, and x1 is the time 1, whereas y2 is I at time 2 minus I at time 1 divided by time 2 minus time 1. Right. So for this first segment from 0 to 2, we will write an equation by following these instructions. I of t minus the value of I at time 0 is 0 over t in general minus the value of the first time t1 is 0 is equal to the value of current at time t2, the second time is 2. We are writing equation for this interval. So at time 2 we have the value of the signal 10 minus the value of the signal at time t1. This is t1. So this 0 0 is t1 I of t1. This is t2 I of t2. So we take these two coordinates. The coordinates for this point is 0 0, t I of t1, t1 I of t1, and the coordinates for this point are t2 and I of t2. So I of t2 is 10 minus I of t1 is 0 over 2 minus 0, t2 minus t1. t2 is 2, t1 is 0. So this is 2 over 5, 2 over 10 over 2, 10 over 2 means 5, minus 0 means nothing, and if you multiply this 5 on the other side of the equation, I of t is 5t. So from 0 to 2 the equation is 5t, and then we can integrate, square it and then integrate for to compute RMS value for this segment. Right, from 2 to 4 it's constant at 10, so this is constant 10. From 4 to 6, from 4 to 6, this is again once again a straight line, but this straight line is decreasing, so we need 2 points in order to write the equation. Let's write it. Let's take it as the first point. The coordinates are on x-axis we have 4, on y-axis we have 10. Here the coordinates of this point are x, on x-axis we have 6, on y-axis it is 0. So it can also be written as t1 I of t1. This is t2 I of t2. So we can put the same in this equation. I of t minus I of t1. I of t1 is 10. So I of t minus 10. T minus t1. t1 is 4. I of t2 is 0. 0 minus I of t1. I of t1 is 10. t2 is 6. t1 is 4. 6 minus 4. So we can solve it. This is minus 10. This is 6 minus 4 is 2. So minus 10 over 2 is minus 5. So multiply this. This becomes minus 5t plus 5 4s are 20. Or I of t can be written as, taking 10 on the other side, this is minus 5t plus 30 amperes, or whatever are the units, minus 5t plus 30. So this is minus 5t plus 30 in this span, and from 6 to 8 it's a constant at 0. So this is 0. So this is how we can describe this signal I of t. And in order to find RMS value of this signal, we know in order to find RMS, we compute these three operations in reverse. First we square the signal, but since signal is distributed in 4 portions, we'll square each individual portion. 5 squared, t squared, and then mean, computing it from, and this has the range from 0 to 2 dt, plus then from 2 to 4, this is 10 squared dt, plus then from 4 to 6, this is minus 5t plus 30 squared dt, then plus from 6 to 8, this is 0 squared dt, and then we have to, once we have squared it, then we have to compute its mean value, squared, integrated, and then divided by the time period, and then you can solve it to find the answer. Thank you.